Welcome to B-Sides. This presentation is simplifying your regex environment. I'm Cary Petterborg, and I'll be your host today. As some of you may already know, I like regular expressions. Many people think I'm crazy, like my wife, but she thinks I'm crazy for reasons other than my affinity for regular expressions. You can find me hanging around in the Splunk user groups under the assumed name of CP Regex Guru, and I'm also in answers as C. Petterborg. You may be wondering why I'm talking today. I know I am. I've had a long and storied career. As you can see, I've been a professional software engineer for more years than many of you have probably been alive. I've been using regular expressions almost that long. Splunk has allowed me to use my love of regular expressions because of all the places that you can and oftentimes have to use regular expressions. I've been working with Splunk since 2011. I'm a member of the Splunk Trust since 2017. I work for Stage 2 Security and I work on the contract at Adobe. I've attended every Splunk conference since 2012. I have the hoodies to prove it. And I presented there 4 times now. I'm quite excited to be able to present here at Splunk B-Sides this year. This is a common quote that I often hear from people, and I think it's because people find regular expressions to be difficult to understand and use. But I don't personally think that this quote is always true. Hopefully I can help you to understand regular expressions better. There is a fine line that you have to walk with regular expressions. Sometimes you should use the simplest expression possible, and sometimes you shouldn't. If you choose to do only the simplest regular expression, you choose the sometimes easiest method for developing or modifying them. Though that isn't always the case, modification and understanding may not be your only goal. Speed can be vitally important in many instances, and even then, the simplest regular expression may not actually be the best way to simplify your regular expression environment. But because sometimes the simple regular expressions can take a lot of processing time, often breaking the problem down to the point of using one regular expression per field extraction can be massively more complicated and process intensive than using one larger, more complicated one. So how do you decide when to use a regular expression and when to use a more sophisticated, complex one? That's what you're here to find out. First, let's look at the pros and cons of using simple regular expressions. First, the pros. As you can see, each item in the list has the word usually behind it. That's because it's not necessarily objective, but often subjective. You'll have to weigh this for yourself, depending on the circumstances of the data you're dealing with and what you need to do with that data. The same for the cons. They need to be weighed in every case as well. As you get more experience with regular expressions, that will become more of a second nature to you. The trade-offs of using a less simple, more sophisticated, more complex regular expression are pretty much the opposite of the pros and cons of the simple regular expressions. No surprise there, right? But I needed another slide, and I used different words in case the last slide didn't explain it well enough. Sometimes doing something more complex is better than doing it simply. That's kind of like going to McDonald's and ordering your hamburger and paying it, then ordering the fries and paying, then ordering a drink and paying, then ordering a cookie and paying for it. You're getting things done separately, which is simple. Each individual thing is a simple step, but that may be more time-consuming and cumbersome. But if you're just ordering a Happy Meal, the simplest method works. I completely agree with old Albert here. I try to follow the KISS rule. Keep it simple, stupid. Or in other words, keep it stupid simple. Going too simple will introduce new problems. And this talk isn't called making your regular expressions simple. It's called simplifying your regular expression environment. So, drop back. Think about what your goal is. Then approach writing your regular expression with that goal in mind. What's the purpose of a regular expression? Is it to extract fields, do text replacement, or just to identify an element of the data coming in? If your goal is to just make things as easy to understand as possible, then you may choose a different path than if you need to have a reliable one, or even one that is extremely efficient. The purpose may be the key. Field extractions are at the heart of Splunk. Whether you're dealing with the field extractions at index time or search time, field extractions give you more power over your data. They make searches more simple. In certain instances, it may seem that if your event is a long string of varied data bits, that it would be easier to have each field extracted using separate regular expressions for each field. While in theory this seems logical, it is most likely not going to allow you to achieve your goal of simplified and efficient. In fact, one long regular expression may be more efficient and even easier to understand than several simple regular expressions. Does this surprise you? You can have your cake and eat it too. Let's see why I can say that. Now, I just like this quote. It seems to fit here. If the field extractions are done using separate regular expressions, then each regular expression will likely build upon the previous one. If you make a mistake in one of the field extractions, you may end up having to make a change to each following regular expression. So then you haven't made just one mistake, but several. When one regular expression depends on another, building on the experience of the previously extracted fields, if you make a mistake early in that chain, then you make a mistake for each regular expression upon which it was built. Then you must modify each regular expression that was built upon the erroneous one. I'd rather make a mistake that was correctable once in one spot than to go back and change each of several broken expressions, particularly if you need to remember each regular expression that's in that particular chain. Here's an example of a regular expression from the field extraction tool built into Splunk. The regular expression is being used to find two fields, the client IP and the user agent. As you can see from the regular expression that it used, it's quite simple, given the length of the event and the complexity of the field extraction. For this specific event, it works fine. The regular expression, as you can see in greater detail here, is extracting the client IP and user agent while skipping a bunch of stuff in the middle. That worked on the entire event we saw in the previous slide, but it doesn't match all the events in the data set. I put that regular expression into regex 101, my favorite regular expression tool, by the way, to look at a larger data set, and found that I wasn't matching many of the events properly. It failed with each of these pictured here. In this case, the regular expression needs to be updated so that it will create the field properly. If I had used the field extraction tool output alone to find several different fields and did them with several different field extractions, then I would probably have to go back through all of them that were built on what I had perceived was the correct expression to fix any of them that were extracting the fields incorrectly. Sometimes you have different people that want to get similar but different field extractions from the same events. So you end up with several different field extractions going over the same data. So they use the field extraction tool to get only the things that they want from the events, causing there to be a duplication of effort in some cases and wasted CPU cycles in most. Here's another view from the field extraction tool which shows the same discrepancy in the extractions. In this case, the data would have shown the problem, but there could easily be cases where this type of problem would not be found for days or weeks as new servers logs are brought into Splunk and are examined. Here's a regular expression that has been substituted for the field extraction tool's regular expression. that matches the set of most of the fields. This also caught the problem in the field extraction. The first problem was actually quite a simple one. Note the HTTP information in these two separate events. One has a space, the other has a slash. Here and right here in the middle. This was the cause of one error. Any regular expression that was used to extract fields from this could have had problems extracting fields correctly. When you go back to fix the regular expression for this problem, if there are several different field extractions, you'll have to go and check and fix them all. If there were just one field extraction for this type of data, then only one field extraction would need to be fixed. The next problem is a little harder to spot, but right after that HTTP version comes the args field, which is missing in the first event. Fortunately, here we have a complete set of events to look at the data. This is not always the case. As new servers are brought into Splunk, new and different events can break some regular expressions that would have worked on the initial events that were indexed. Then you have to go through and change those varied field extractions. Now this regular expression is fixed with some minor modifications. If I had to have gone back through the multiple field extractions to fix them all, it would have taken much more time than make the change to this one field extraction. So the more maintainable situation in this case is to have a single regular expression for the entire event set or source type. I'm told all the time that I have some crazy regular expressions that I make, but that they work magic. I don't think that this case has been a crazy example, but it would have been crazy to have gone the other route and used simple regular expressions. Remember, keep things as simple as possible, but no simpler. That's how you simplify. Now we'll have to finish off the video from earlier in the presentation. Fail often, fail fast is a term commonly heard in Agile development. If you are failing often, then you are making changes often. If you are paying the cost of fixing those mistakes, maintaining many regular expressions, then you will want to reduce the number of changes for each mistake by reducing the number of regular expressions. We're going to now look at some of these advantages to using more complex regular expressions. The first 3 points seem to have been covered by my last example. When extracting multiple fields, making a single regex can often be your best option. Another big advantage is fewer backtracks. When the regular expression engine backtracks, it performs another match attempt at a different position in the pattern. This can lead to inefficiencies in the parsing, thus some more computing resources. We want to reduce backtracking as much as possible. For that reason, it might be more performant to use separate regular expressions for different formats, though that is not always the case. Next, I'll show you an example where it is better to use one regular expression for all the field extractions in terms of computing power. Here's a set of events that are an example of using separate regexes for different fields. In this initial example, the first field will be extracted using its own regular expression. This screenshot shows the number of steps. The steps are an effective measure of the performance of the regular expression on a given set of data, and lower numbers are better. The step count is 256 for this first field. The second regular expression requires 320 steps, and this third field requires 384. In this expression, we are only getting the HTTP status code, which requires 960 steps. If we add all those together, then there are 1,920 steps to get 4 field values. Now, using the same data set in this example, there are 10 fields extracted, and it takes only 1,632 steps to get all 10 fields extracted. So doing separate regular expressions takes 1,920 steps for 4 fields versus 1,632 steps for 10 fields using a single regular expression. The reason I mention this is in the context of Splunk is that there are many installations of Splunk where there are overlapping regular expressions that will be used on the same data, which may get separate fields because it was easier or because separate people did separate field extractions. Look at the set of field extractions to see if there are cases like this. It will be more efficient to use one field extraction regular expression than several disjoint ones. Slow and steady wins the race, right? But what if you can be both fast and steady? Aren't you going to win the race too? The hare's problem was that he thought it was going to be a simple race. If he had just the steadiness of the tortoise, he'd have won. Another thing frequently found in Splunk instances is a field extraction which doesn't get all the data correctly extracted, even though it seems more efficient because it's simple. Don't be fooled by these. They can have significant effects on both accuracy of the data and the efficiency of the parsing. Here's a very good example of data and an associated regular expression that could easily cause problems. The regular expression seems to be accurate and simple, finding the username quite well. Please note the event in the middle, which has 2 matches, is the one that appears to have the username disconnect and disconnected found in them. Right here, disconnect and disconnected. These are wrong and should not be found in the event. So that's the first problem. Data integrity. You can't trust the data after the field extraction being done this way. Note also that it requires over 40,000 steps on this set of data. That is the second problem. Here we have a regular expression that is more complex and correctly identified the username in every instance in the event set. The line that was a problem in the previous slide is no longer a problem. Not only that, but the step count is down from over 40,000 to less than 5,000. That's almost an order of magnitude more efficient. Here's that line, disconnect, and it no longer has the incorrect users flagged. I'd like to supply a few simple tips to help you make your regular expressions easier to read and understand, which will help you maintain them. Readability is one of the reasons that people opt for doing simple regular expressions, and I'll echo that opinion in most cases. There are things that can make the readability better. Using double quotes, slashes, backslashes, etc. can make it difficult to read the regular expression if they crowd out the other meaningful parts of the expression. Many people don't know that you can use alternate characters in some regular expressions, like the sed mode regular expression. In particular, the slash character is usually used in these expressions, when possibly another character may make more sense because there might be slashes within that expression. In this case, the set of slashes and backslashes can make it difficult to read, and especially in larger ones, larger than this simple example. It can be hard to know which slash is the one that is the middle character of the expression. Fortunately, in this example, it isn't hard to see the 3 slashes, but you could easily see how it could become quite difficult to read properly. If instead we just substitute a hash for the slash, then it instantly becomes more readable. There are only 3 hash characters instead of 4 slashes and 1 backslash, which becomes difficult to distinguish. I've also seen many cases where people just don't know which character to escape with a backslash, so they end up putting backslashes before so many characters that it becomes illegible. Only escape the characters that need to be escaped, and not every character that could be escaped. Use this tip. You'll thank me. Line-breaking regular expressions are sometimes made more difficult than they need to be. Long expressions are sometimes implemented when a shorter one will do. And if you don't need a line breaker at all, don't use one. That case would be when there's just one line per event. Just make sure that there are no multi-line events in your data before you commit to that approach. Here's an example of a line break or regular expression for breaking up the events. It's very exact in catching the entire date string and will certainly be a valid line breaker, but it doesn't need to be so complex when something simpler will do. This line breaker takes 116 steps to match. So to use a real-world example, why dig a hole 116 inches across when a 45-inch hole will do the job? This expression does the same thing as the previous one in almost every event through to the next century, because there is little chance of a line starting with 20 plus another digit that isn't the beginning of an event. If you find that there is, just add a little more to the expression. Adding a fourth digit will only make it be 49 steps, and a dash will only make it be 53 steps. Those are definitely better than the 116 steps. And when that regular expression is being used to parse each event of that type coming in, it can save a lot on CPU cycles at index time. Actually, this is just to make a point about the reuse of regular expressions. Just this week I was reviewing some code where a couple of regular expressions were just copied from another app without really knowing what the expression would do to that data. As it turns out, they did nothing because they didn't match the data at all. Review any regular expression that you are reusing or have found online. You should try to understand the expression. And if you don't or can't understand it, at least try it out on valid data and see if it does what it should. I use regex 101 all the time in testing and creating regular expressions. It's a great tool and it's free. I suggest that if you like it, you donate to the developer. I have, and the developer is very nice. Also, the regex channel on Slack is a great place to learn more about regular expressions. We occasionally have regex challenges where you are challenged to reduce the number of steps for a regular expression or the number of characters that are used in the regular expression. There are many other regular expression games and websites that you can Google and have access to great learning tools. Now, if there are any questions at the end of this presentation and there's time to field them, I'd be happy to field those questions now.